Okay, guys. So we are now doing the applications of our trig functions. I forgot speakers today, but I'll bring them on the review day to show you just some videos of like where sinusoidal waves happen in real life. Okay. One place is with the Ferris wheel, though. Has everyone ridden the Ferris wheel? Yes. Okay. You haven't ridden one though? Okay, that's okay. I said maybe we need a field trip to go ride a Ferris wheel, but so if you think about it, your distance from the ground, if you ride around the Ferris wheel, do you guys see how that's not going to be a linear relationship? Okay, yeah, so it's actually a wave. It looks like the sine curve. So we are going to graph this based on a sine curve or a cosine curve. So we've got a few things to look at here. This is where you are when you start, okay? And we'll come back to the 7 seconds to reach the highest point. When you're at the highest point, you are 55 feet above the ground. So I'm just going to label that up here. That is 55 feet. Highlighting all the important stuff here for you. It takes 22 seconds to do a complete revolution. I'll come back to that. And then the diameter of the Ferris wheel is 50. So from the top to the bottom of the Ferris wheel, okay, good. That's 50 feet, right? So where is the lowest point on the Ferris wheel? Not at 0. 5, right? Because the highest point it goes is 55, diameter is 50. And does that make sense? You're 5 feet off the ground? Okay, we don't really want to be right on the ground because then you're crashing every time the Ferris wheel rolls in. That's not good. We don't want that. Okay, so a few things we can figure out from this. We're going to figure out where our midline is, and we're going to figure out our amplitude. So what do you think for amplitude? Diameter is 50, right? That's the whole height of the wheel. So what's half of that? That's your amplitude, okay? So where does that put your midline? At 30, right? Everybody see that's halfway in between 5 and 55? Or you've added 25 or subtracted? Okay. All right, so if the midline is at 30, that means we have shifted up 30. Yes? You with me? Okay. We're going to do this as a cosine equation because it's so much simpler. If you think about a cosine graph, you don't have to write this down. This is what cosine looks like, right? Yeah. This maximum, it's on the y-axis every time, or when x equals 0. Okay? Much simpler than using the sine equation. So if we go back here, it tells us it takes 7 seconds to reach the highest point. So that means instead of happening here, it has gone, 1, 2, 3, 4, 5, 6, 7, and now it's at the maximum. So you guys see how your graph is just shifted to the right 7? So we can do that on our equation here. So we know we're going right 7. Okay. What's the piece we're missing? Period. Okay. Did they tell us anything about how long it takes to do one full cycle around the Earth? 22 seconds. So you know the period equals 22 seconds. But that's not what we're going to put in our equation. Okay. Good. So you do 2 pi over b equals 22, and we get b is pi over 11. Move that up a little. Okay, are you with me on all the pieces of our equation?
Yes.
Okay, so normally, if we're dealing with cosine, this is the maximum of cosine, right? And that happens at x equals 0. they tell us that the maximum for our Ferris wheel ride happens 7 seconds after it starts. So if you think on your x-axis, this is 0 seconds. 1, 2, 3, 4, 5, 6, 7. We know the maximum is there instead of here. So it just goes that way. That's it. Do you guys see how it'd be much more complicated with sine? Because your first maximum is normally at pi over 2. We don't want to figure out where we've shifted from pi over 2. Okay? So just use cosine every time. So then your equation, you're just going to write y equals, all right, my amplitude is 25. I'm using cosine. My b value, yep, pi over 11, parentheses, x minus 7, parentheses, plus 30. That is the equation that models the distance from the ground as you ride the Ferris wheel. So guys, don't just read the whole paragraph and try to write your equation. Like, find each little piece of information that you need, find your A, B, C, and D, and then plug them into the equation. Okay? You will need your calculator for the next part. So go ahead and get that out. If you don't have one, make sure you're near someone who does, and you guys can work together.
I don't know if this calculator will get
Is that a Casio? It's allowed. It's just when I show you keystrokes, it's very different. You may be Googling a lot of things. All right, guys, so there's 2 ways you can figure out the next part. First, since we're dealing with pi over 11, do you think we want to be in degrees or radians? Radians. Check your mode for me. Just make sure you're in radians. Okay, do we know where that is? Okay. You can take the time to type this in and go 25 cosine pi over 11, parentheses, 15 minus 7. You can type that in for 15 and 30, and you know, every time you plug it in. Or you could go to your y equals and type in this equation, and then use the table function on your calculator. It's easier. Okay? Make sure you've got enough parentheses depending on what type of calculator. And then when you go to your table, you can actually change your table, like where it's going to start. If you push second window, it gives you that option. So you can start at 15 or you can start at 30. Guys, I'm going to give you the first answer just to make sure, like, okay, yes, you've got everything keyed in right. So at 15 seconds, you should be 13.628 feet off the ground. Okay. I'm also asking you about 30 seconds and then 2 minutes. For 2 minutes, do you think I look when x equals 2? No, what do I look for? 120, right? We're just make sure you're in the right. So guys, I'll be walking around. If you're not getting these or you have any calculator troubles, let me know. Or if you're not sure about the table part that I'm talking about. And that's one where you recognize like having. That's great. Anybody ever here having any trouble? Yes. As long as you're fine, you can't just trace it. Actually, sit on the edge. That's fine. Can I show you the picture? Starting then when you go but yeah, the other way works fine. Let me write up your answers for 30 and 120. Did you get 53.987 feet? Okay, and 46.372 feet? Yes. All right, is everybody okay with B? Are we ready to move on? Okay. All right, so C, it says, what is your initial height? So guys, look over here. This is where you are. You're hanging out in this little basket right here. Your height is not 0 feet, right? It's also not 5 feet because you're not the last little basket to get loaded. So how would you figure out what your height is? 0 what?
0 time.
Yes, 0 times. So plug 0 in. So x equals 0 seconds. And let's see what you get for your height. What'd you guys get? Negative 24. So you crashed into the ground. We had some very bad technical difficulties with it. Okay, maybe not negative 24. Anybody else? 19 point. Yes. Okay, let me come back and look and see what you get here. Okay, so for D, how much time has gone by when you first reach a height of 45 feet? I would graph for this. So in your y1 is your equation with the cosine and everything, which I think most of you already put in. What should I put in my y2? 45, and then we are calculating the intersection. Now it says the first time you hit 45 feet. If you think about it, going around and around on this Ferris wheel, you're going to hit 45 feet on the way up, and then on the way down, and then on the way up, and then on the way down. Okay, so make sure you pick the one closest to the y-axis. All right, let's see if we can figure out why you're getting negative.
That's all. That's all. I don't really know what I did. What did you
So let me show you. Yes. So then,
This guy's know by now.
so we want that.
That's not what I hear.
We're usually Okay, so what did you get for D? What did you get for your time?
45.
Okay, no.
That's what he wrote on this paper.
Why are you here instead of him? 3.753 seconds. You probably wasn't done. There is a 45 in the problem.
That's not stupid. Just
Is Jack skipping class?
No, Alright guys, so let's look at letter E then. How much time has gone by when you reach a height of 45 feet for the second time? So you've got to find that second intersection. 10.247 seconds. How are we doing on these? Yeah. Is anybody struggling with the intersection part? Like, do you guys remember how to do that? Yeah, Faith.
I don't want to talk. I don't know what happened.
Okay, so
I don't want to talk about that one. I don't know why.
all the way around. So we really
You have 7 feet left. 10 feet left after
Trace. Ferris wheel.
I swear to God, I agree with it. And I believe the whole.
Alright, yes.
I mean, when you like stop, when do I stop?
Alright, so are we okay with the Ferris wheel? So you guys get to try one now.
Yay.
Alright, we are water wheeling and dealing, okay? So very similar idea. I want you guys to try this one. So figure out that A, B, C, and D for your equation, okay? You need the amplitude, you need the period, you need any phase shift, you need any vertical shift.
How? I did the exact same thing. What trade?
All right, guys, make sure you're working on this. All right, guys. All right, back to your water wheel, guys. And you guys know I'm like recording you today, right, for Blackboard? So. I'm recording class today for Blackboard. So.
The recording will show that when we're thinking more up.
It's audio and it's what's up here. Like it records the screen and what's here. So. Guys, shh, more math. Here.
No way.
they do some calculations. She's still
How are we doing on the equation, guys? I don't really want you to do the rest of it if you have the wrong equation, so let's make sure.
Wait, is it cosine? Give me like 1 more minute.
I would always do it as cosine, it's so much easier.
Just give me 1 more minute. You want to do it as
It's going to affect the phase shift, like the sideways. You won't just be able to go 2 to the right.
No, so like the Harrisville one, you want to do it as a sideways.
So that would change the 7. Like you can't just say x minus 7 in that one. Because you'd have to figure out, well, sine's first maximum is normally at pi over 2. Period has changed, so I need to figure out based on the period what that first maximum is compared to 7, and then figure out how far away from 7 I am and shift that. So it's much harder, yeah. Really, I'm trying to make it easier.
I'm thinking right now.
Do we want to look at the equation?
Yes.
Okay, so I'm going to draw on here. Well, water level, guys, that's at 0, right? Let's think about what the highest this wheel goes up to. What do you think? Okay, this is 6, right? And the radius is 7, so that's 7. So 13, because the bottom of this wheel is actually down at -1, right? Okay. Where is your midline? 6. Okay, so what is your amplitude? 7. Your midline was at 6, so we know we're going up 6, right?
Yeah.
Okay. Then they tell us the maximum happens, what, 2 seconds in? Okay, so we know we're going right 2. Now the period, it said it can do 6 revolutions per minute. So how long does it take to do 1 revolution? Okay, so the period equals 10. So 2 pi over b equals 10. What does that make b? Pi over 5. Good. All right. So, what's my equation going to be? Y equals, and guys, please get in the habit, if I say write an equation and you don't include the y equals, you will lose points. Okay? Y equals, I heard 7. Okay. So yeah, that is your equation. Why do you need an umbrella in the middle of that? It's not your umbrella. Okay. I don't know the issue. You don't need an umbrella today. Okay. So it's 6 revolutions per minute. There's 60 seconds in a minute, right? So if I can do 6 of them in 60 seconds, how long does it take to do 1? Is that all you need? Yeah. Okay. All right, guys, try to fill in B, C, and D for me. You guys are struggling with your window at all? Let me know. For letter B, are you getting 1.886 feet? Usually it goes 3. On the AP exam, most things they want you to go 3 places, so we'll just practice on that. Are you guys ready for C? Hopefully. Did you get time equals 6.139 seconds? All right, I'll give you a second here to make sure everybody gets used to it. So, your height, if you're at the water, what is your height? So do your y2 equals 0, and then look for the intersection. Basically, it's when do you hit the x-axis. Trace. Guys, this should actually be 6.395. Is that making you feel better? Or not? Yes? No? Ooh. Well, let me look at your equation. Did you have the right equation in?
It's written out here.
Why did you distribute it?
Because it won't let me put it
that's why. Seriously. Like, let me write down the right answer.
Well, you put them in like half page.
That's why, like, when I label this, put, like, I'm drawing that line at, that's the line, okay? Let me write up the answer for D, just 8.163 feet. Yes? Any good questions? All right, guys, so in your packet, if you flip to the homework page for 1-7, if you notice the front, we did both of those together, okay? So the back is all that is due next time. So you just have two problems. Two problems. Just the back of the worksheet is due next time. Next class will be a fate quiz and review. The class after that is your test. You already have the review packet if you're like, oh, I have a bunch of time this weekend and I want to start on it. Okay, so that is already in here, the review. Okay.